Hello everyone, and welcome to another Lancaster Safety Webinar Wednesday. If this is your first time joining us, welcome. We hold these free webinars once a month and invite everyone to attend. Our clients have the added bonus of having instant access to all of our safety and health webinars, newsletters, checklists, toolbox talks, training guides, and more. We're a full-service OSHA management company who truly believes in taking safety beyond the OSHA standards. My name is Marcy, and today we have one of our occupational safety and health trainers, Mike Rubio. Mike has spent 12 years giving businesses the necessary training, knowledge, and tools to succeed in maintaining a safe and healthy workplace and workforce. Mike continues to deliver excellence as one of Lancaster Safety's active trainers and consultants. He has seen firsthand how dangerous working in the trenching industry can be, and just what types of hazards are most common as well. He's here today to give his professional advice on how to prevent trenching and excavation accidents from happening. A little knowledge goes a long way. Mike, thank you for being here, and I'm going to turn the presentation over to you.
Thanks, Marcy. Yeah, this is a topic of pretty significant concern for a number of reasons, many of which we'll discuss as we go through this webinar. And like a lot of our other topics that we perform training on and complete webinars for, the goal is to increase awareness and hazard recognition. Ultimately, that's a pretty significant part of being able to identify and correct hazards while out in the field. There are a lot of variables that can come into play with this type of work, so our hope is that we'll hit on a lot of those. Let's start by discussing and going over the outline for today's webinar. We'll talk about some statistics. The hope is there that with some of the statistics shared, we'll be able to reinforce the significance of the impact that this type of work can have on an employee. We'll give you an idea of some current fatality numbers and overall incident rates. We'll also talk about competent person requirements. Every single site where trenching and excavation work takes place, there has to be a person there who's essentially going to be in charge. They have the ultimate responsibility for the employees on site, and at the end of the day, they should also have the authority to make whatever changes are necessary. So just being able to identify a problem is just half of it. Being able to actually set the wheels in motion and get things fixed before they turn into a more significant issue is critical. We'll go over a bunch of different types of routine site hazards as well. Some of those may not apply directly to trenching, but there are a lot of things that an employee may face when they're out in the field on a site. We'll also go over and review a bunch of different types of OSHA compliance officer site assessment questions. So these would be very similar to the types of questions that a compliance officer may try to answer themselves or investigate. Certainly ask employees on site or perhaps even the competent person. And then we'll round out the webinar by going through the different types of soil as well as some employee protection options. So starting off this part of the discussion with trenching statistics, you can see from the statistical information that I've listed on this slide that construction workers account for a relatively small percentage of the overall workforce. It's roughly about 10 million people in the United States. However, they account for roughly 26% of the occupational fatalities each year. Now, if we break that down even more and talk about excavation related activities compared to other trades, those people are 2.5 more times likely to die in excavation. And the situation is such that if an employee is caught in a collapse or a cave-in due to the weight and force and pressure that the material can impose upon their body, our bodies are just not designed for that. If a person survives the initial impact from the soil, in most cases, if a person's upper body, their chest is encased or engulfed, that has a tendency of pushing the air out of the lungs, and most people are going to suffer significant or permanent brain damage after the first 3 to 4 minutes and ultimately death. So the risk is great. I think we'll be able to reinforce that as we go through the remaining information found in our webinar here today. 1 cubic yard of soil can weigh about 2,000 pounds. So to put that in perspective, most commonly produced passenger cars currently are roughly around 4,000 pounds. Now, we add water to the soil, a cubic yard could weigh, upwards of 3,000 pounds. The thing is, a cubic yard of soil is not a lot. In typical cave-ins, especially if a spoil pile is stored too closely to the cut, you can have multiple cubic yards of soil breaking loose at one particular time, in one instance. So it may not be all that uncommon for a great deal of material to fall on an employee and subsequently encase them. According to the BLS, there were 130 fatalities during the years 2011 to 2016. I don't have current data from last year as of yet. That's not been published. The hope is that over the last couple of years anyway, at least from 2016, these numbers have declined. We started to see a bit of an uptick or an upswing in fatality numbers related to trench work in 2016 alone. I believe those numbers doubled from the 2 previous years. As far as OSHA's National Emphasis Program is concerned, we'll talk about what it is. There are situations that arise in various industry where OSHA will focus their efforts a bit more. And this is one largely in part due to the significant numbers that we saw a couple of years ago. What this essentially means is that they're going to spend more time. They're going to be more active. They're going to be more involved in not only OSHA outreach and assistance in training, but also enforcement. Can any company be picked? While this emphasis program is going on, this current emphasis program for trench work, which it's been in place since October 1st of 2018, the first 3 months were geared a little bit more towards awareness and assistance, and then after that, we're subsequently beyond that right now. After that, we're going to see more on the sides of enforcement. But can any company be picked? The answer to that is yes. Compliance officers are essentially now instructed to stop if they see trench and excavation work being performed. So they don't need a specific reason. There doesn't have to be a referral or a complaint or a death or a significant injury, although they will actively go out and inspect those instances as well. But it may be exceptionally random. A person could be traveling to and from a location and they can see some work that's being performed and just decide to stop. So how would a company prepare for such an impending inspection? The answer to that is really no different than how they should be performing work on any given day. They need to develop a safety plan, whatever written programs that need to be in place that outline areas of responsibility. They need to be able to effectively implement that within the company structure. They also have to be able to train and thus prove that training has been completed for all exposed employees, and then ultimately maintain that. Once you get everything in place, you have to be able to maintain that system in an effective manner. You have to just keep sharp with this. I mean, this is something that I think most companies who perform this work already know, that they have a high level of exposure out there because they're in the public eye. I mean, most trenching and excavation related work isn't done behind closed doors, so you have a lot of outside influences and people watching you to begin with. The simple fact that a compliance officer could just stop at any point in time, I think bodes to the fact that you have to be on your toes 100%. Before you start, before any earthwork begins, I mean, before somebody even sticks a shovel in the ground, every effort should be made to identify underground structures and utilities. That's a hazard that we'll discuss a little bit later on in this webinar. But ultimately, if a company digs down into some type of utility utilities or some other type of structure that could be exceedingly hazardous for an employee nearby, as well as quite costly for the company. Competent person requirements. So this is something that I mentioned at the start of the webinar that we'll hit on, and ultimately we're going to discuss a lot of the different types of conditions and variables that a competent person should be able to identify as we progress through the webinar itself. But at a minimum, what that skill set should include would include being able to identify and know and understand safety requirements, being able to identify soil type, soil mechanics, and be able to perform an assessment or inspection to determine the soil type, what protective systems should be used, and other types of supporting equipment, and then being able to determine if there's a potential for a hazardous atmosphere or some other type of hazardous condition that could affect an employee when they're in subsequent trench or excavation. How often do inspections need to be conducted? Typically, this is something that needs to happen at the start of the shift, the start of the day, before an employee ever steps foot in a trench or excavation, as well as continuously. I mean, conditions change. Like I said before, there are a lot of variables that affect soil stability and structure. Most job sites, there's a lot of activity. You could have movement of mechanical equipment, you could have movement of mobile equipment, you could have adverse weather conditions come into play. So it's something that this individual needs to keep an eye on continuously. One time a day is not going to do it. We'll get into some of the various site hazards that employees may encounter when out on a field location. And one of the first ones, you typically can't have trench or excavation work unless you have heavy equipment operation. So excavators, bulldozers, earth moving machinery, compactors, material handling equipment, and the concern here is obviously struck by or caught in between. Employees should make every effort to stay clear of this equipment. Wearing a high-vis vest or some type of vest that has a significant amount of retroreflective material may help, but ultimately you have to make direct eye contact. And keep in the back of your mind that no matter how good an operator is, if you're in a blind spot or you're behind a piece of equipment to where they can't see you, the likelihood is that they're going to have no idea that you're there. So proper body positioning is critical. Vehicle traffic. A lot of excavation and trench work is positioned or performed in such a location to where it's close to a roadway or a parking lot. So that type of exposure poses its own significant risks. One being, ever more the major distraction that drivers have with cell phones and other electronic devices when those are being used. So many states have pretty clear-cut guidelines for traffic control, especially if a roadway or a path of travel is encroached upon. I always try to recommend to employees, though, that they never turn their back on traffic. Never get too comfortable when vehicles are nearby. You just never know when somebody's not paying attention. They're looking at a phone, they're distracted with other things in the vehicle. A driver could be impaired, a driver could fall asleep. And how quickly these situations are going to develop, most employees aren't going to have a whole lot of time to get out of the way. So you really have to go above and beyond to not only protect your crew, but also effectively guide the general public when there are changes in their daily commute. This is another very critical aspect of trench and excavation work, the general public itself. A company has to make every feasible effort to keep other people of the general public out of a trench or excavation. Now, after hours, this could become a difficult proposition. OSHA does not outline very clearly on what has to be done. They provide options as far as covers, fencing, barricades, signage, but they really leave that up to the company and the competent person to make that judgment call. Some municipalities may even have specific requirements for protecting a trench after hours once the company has not performed any work and nobody's there to keep people away. But the last thing any company wants is to have a passerby or a bystander, even if out of curiosity, a small child stumble into a trench somewhere and fall in. Material handling concerns. A lot of times companies are using their own excavation equipment to pick up and move various types of precast concrete structures, piping, and soil and other earthbound materials. So the idea is that employees can get struck by that stuff if they're working too closely or they're working underneath any of its movement. You have to keep your distance from that. A hard hat may provide some form of protection in the event that an object comes in contact with that part of the body, but ultimately you want to avoid even getting into that situation, period. Ground conditions. This is something that OSHA really cannot regulate. There aren't specific housekeeping guidelines and conditions to adhere to for walking working surfaces. So employees are likely to be subjected to slippery conditions, especially in the spring or winter months. There could be a significant amount of mud, snow, ice, water buildup. You could have larger debris that employees can stumble over. Certainly rocks and other organic material that could have been excavated or moved out of the way. A lot of times employees are accessing mobile pieces of equipment, which can be dangerous. So you really have to watch. I try to recommend to employees that they slow down. They take their time. There's no reason to run around on a job site, certainly not jump off anything. But you really have to be mindful of the various trip hazards that are out there. Poor weather conditions. Two major swings in weather. One, it being exceedingly hot. You could be looking at heat stress related illness, and then on the flip side, working in extreme cold temperatures. It's not completely out of the realm of possibility that an employee can suffer frostnip or even hypothermia in some cases. So knowing and understanding when it should be called. Everybody has their limitations. If the weather conditions are posing too much of a significant hazard, whether it be major temperature swings or significant rainfall or saturation, then we have to be able to avoid that. We can't control Mother Nature, but we can control what we're doing out in the weather. Electrical contact, utilities, and various inspections. Like I mentioned before, we have to be able to try to determine what's underground before we dig. So every effort needs to be made to get line locators and other people out there, but that's not a perfect science. We've had clients who have had these individuals come out and locate utilities, and the markings have been off. So you always have to proceed with caution, especially in areas that could have been pre-disturbed or likely some type of work was completed in the past. For overhead utilities, we have to also be mindful of overhead power lines. Approach distances at a minimum should be 10 feet. If a company needs to have somebody act as a spotter, whether during digging or just positioning of equipment, then so be it. The options are such with that if you can't have the lines shut down or insulated or isolated, then you're going to have a tough time performing that work because you can't get closer than 10 feet. Falling and dropping objects. We'll look at some guidelines in a little bit about preventing objects from falling into a trench. There are some spacing requirements that we have to adhere to, but ultimately very similar to the picture you see in this slide. Employees need to position themselves in such a way to where they can't be struck by anything that falls out of a piece of heavy equipment, whether it be soil, whether it be rock, whether it be gravel. So you don't want to be underneath anything. Dust. When we disturb soil and other materials, especially if the weather conditions are prime, we can, particularly dry, we can create dust. So it goes to say that if there are other materials present in that dust, we could be looking at burnt fuels, wood, trash, pesticides that have built up in the soil over time. Obviously, silica is a major player right now. We can turn that harmful material into tiny particles that can become airborne, and employees subsequently can breathe those in. So we have to be mindful of that. Unfortunately, in this training, we're not going to get into all the details of silica exposure, but ultimately there are control measures for reducing employee exposure, Perhaps that will be another webinar in the future. Light and laser radiation. One of the most common would be overhead sunlight. So in most cases, workers that are out in the field performing trench and excavation work, they're clearing the land. They're likely to be clearing trees and other structures nearby. So the amount of shade is at a premium. A person could suffer significant exposure to the sun, and that cause or create a relative health problem. So you have to be mindful of that. I mean, staying covered up with light, loose-fitting clothing, wearing sunscreen should not be frowned upon. Laser radiation, transits, and other laser levels can also be used. There are some pretty strict guidelines or specific guidelines for laser operation in construction trades. Employees have to be familiar of the type of laser, the power, be able to identify related health or risks to their body from overexposure, and then also be familiar with when signage would be necessary to inform other people nearby. There may be confined spaces. So aside from the trench itself, which there's a specific standard for, employees often performing this work may find that their work takes them into a precast concrete section of manhole or a catch basin. So those types of entry could pose major risks, particularly one being a hazardous atmosphere. So there would need to be special precautions taken for that type of work. Now, to round this out, power tool use, there could be a wide array of different types of power tools that are used and operated out in the field. They all have their own individual hazards. Probably one more specifically associated with trench work would be gas-powered equipment. That could be a very common cause of creating a hazardous atmosphere, hazardous atmospheric condition due to maybe oxygen being displaced by the emissions from the tool. Any potential fire hazards, especially this time of the year in the northeast when it's not snowing or raining. It tends, the ground and vegetation tends to dry out and everything's dead. So contractors have to be very cautious that they don't create an ignition source out in the field, perhaps somebody cutting rebar to where they have a significant fire or blaze on their hands. And then lastly, significant atmospheric quality issues. Aside from the confined spaces that I mentioned, depending on what was in the soil, it could be near a landfill. There could have been other materials that have soaked down into the soil over time. We start to dig that material, we start to excavate it, we get into a low-lying area where perhaps there's less airflow or ventilation. Some of those things can become concentrated, and that could be a significant problem. So typically, once you hit a trench that's 4 or more feet deep, where there's a chance of a hazardous atmosphere, companies have to start to perform monitoring. So Marcy, we have the first Insta safety poll question. Let's see if people were paying attention up to this point.
Okay, sounds good, Mike. So I invite everyone to participate by answering this question. When should the competent person perform an inspection of the trench? 1, never. 2, once at the start of the job. 3, before work begins and continuously as conditions change. So please go ahead and cast your vote, and we'll give everyone just a few seconds to finish that up. And we'll go ahead and we'll take a look at our responses. Mike, how did we do?
All right, Marcy. Well, I think we did pretty good. Hopefully we did. I mean, this was something that I spent a little bit of time on discussing. And just to recap that answer, yes, typically the inspections need to be performed before work begins and as needed throughout the day as conditions change. With all the variables that I just got done discussing, everything from weather to heavy machinery and equipment operation, to even just placement and staging of other materials that could be used, that could all have an adverse effect on the soil. So let's take a look at some of the competent person questions. And like I said before in the beginning outline, these are some of the same questions that a compliance officer is likely to try to determine, investigate, or even ask when they arrive at a location. The first question that we have here is the cut, cavity, or depression, a trench, or an excavation. There are differences between the two. I mean, any soil disturbance, either by a piece of equipment or by hand, is considered an excavation. A trench is typically deeper than it is wide. So that's why the majority of these requirements apply directly to trench entry. I mean, you could have an excavation that's a football field in size, and if somebody's standing in the center of it, it's not likely to pose any significant cave-in hazards until they maybe get to the edges. So there is a slight difference there. You want to be able to differentiate between the two. Is the cut, cavity, or depression more than 4 feet in depth? Typically, once you hit 4 feet, like I just got done mentioning, there needs to be some effort to, or requirement to be able to identify a hazardous atmosphere. You know, the other, which we'll see here in a little bit, is ladder access. An employee has to have a way in and out of the trench aside from having to climb up a vertical wall. That requirement comes in at a depth of 4 feet. Is there water in the trench or excavation? Typically, the inclusion of water is going to likely result in soil stability issues, as well as possibly covering up other potential hazards that an employee can trip or fall over. So that essentially has to be removed. You know, an employee is not permitted to work in water. Are there adequate means of access or egress? So that kind of goes back to the mention I just got done making about having ladder access. Another option for that would be an earthen ramp that could be dug in and out that's walkable. Are there any surface encumbrances? So are there any structures, this could include a sidewalk, this could include a tree, this could include other utilities nearby that could be undermined by the work. You know, obviously, if there's a chance that something like that can happen, those have to be properly supported. Is there exposure to vehicular traffic? That was one of the main site-related hazards that I brought up earlier. I think the hazards are quite evident at this point from us discussing it. I mean, you have to do everything that's humanly possible to keep vehicle traffic out of the work zone. Are adjacent structures stabilized? I mean, typically, these types of structures, if we're talking about a building or a thoroughfare or a sidewalk or a bridge, a registered professional engineer is likely to have to design that system. Does the mobile equipment have a warning system, particularly a backup alarm and audible horn? You have to be able to communicate with other employees nearby, and that's just a straight requirement. That equipment has to have an audible alarm. It needs to be, people have to be capable of hearing it outside everything else that's going on. Is there a competent person in charge of the operation? Somebody, like I said, has to be designated as this individual. If there's a problem or a compliance officer shows up, everybody just can't point their fingers at one another and say, oh, I thought that was their job. There has to be an individual who's responsible for this. Like I said at the beginning of the webinar, there are a number of requirements that have to be upheld, and this should be planned out well in advance of showing up at the site. Is equipment operating in and around the cut, cavity, or depression? A major factor that equipment can play on soil stability is just causing vibration and the breaking apart of that material. So if there's a significant amount of movement of heavy machinery and vehicles, additional barricades or supports might have to be put into place. You know, obviously, the last thing any company would want would be a piece of equipment or a vehicle to move far enough to the edge of a trench where it could fall in, possibly on people down below. Are there procedures required to monitor, test, and control hazardous atmosphere? So like I said before, typically once you hit that depth of 4 feet, it's loosely worded that when feasible, and when those conditions could be recognized, monitoring shall be completed. We're not going to get into a lot of other specifics about performing monitoring at this time, but I can say from my experience in going out to other companies, I've witnessed and discussed and talked about a lot of really unique situations that a lot of people wouldn't really have guessed that they happened, due to the breakdown of organic material. I mean, even an animal dying and decomposing nearby or in the work area, that could have an effect on oxygen content and how that is being displaced. And that could ultimately affect workers if there's not an effort made to determine it. Has there been a determination of soil type? So we'll take a look at some different ways to determine that. Was a soil testing device used to determine it? You know, there are some methods that can be used. Unfortunately, a lot of them are subjective, and a lot of them depend on the type of material that was sampled. You know, there are a couple of mechanical devices, you know, one being a pocket penetrometer that's pretty widely accepted in the engineering community, but we'll take a look at that in a moment here. This is a very common deficiency, is the spoil pile placed a minimum of 2 feet out from the edge of the excavation or trench. And we'll talk a little bit more about that here as we go through this, but this gives you a pretty good representation of what I was talking about. The amount of material also has impact on the distance from the edge of the trench. 2 feet may not be enough. That is the bare minimum. So if there's a chance that there could be, you know, some type of a spoil pile or lip slide, and material could subsequently fall in on a worker that's below, remove the material, push it back, put up barricades. Now, this doesn't just apply to soil and rock and other excavated material. It applies to everything. You're not permitted to have anything within this 2-foot space. No tools, no equipment, no materials. That has to be dead, empty space. That's a very common violation that we see. Employees and companies allowing placement of said materials in that area. Do trench shields extend at least 18 inches above the surrounding area? That's a straightforward requirement. You have to make sure that you're well above grade so items can't roll and fall into people who are now essentially trapped inside the trench box. You know, they don't really have anywhere to go. So if a large amount of material decides to slide or roll or move, or it's kicked, if you don't have that excess sticking out above grade, it's likely to fall inside. This last one, if trench shields are used, is the depth of the cut more than 2 feet below the bottom of the shield. So you're not permitted to have any more than 2 feet worth of exposed material below the box. So that's the limit right there. And that could vary depending on the stability. Certainly the chance of somebody being completely engulfed by 2 feet or less exposed material below the box is unlikely. There could still be a situation where something breaks loose and it falls and smashes an employee's foot or hits them in the lower leg. Are there any required surface crossings? So this topic often doesn't come up in trench work, but we have to also be concerned with fall prevention. And in construction trades, it's 6 feet. So if we have to cross a narrow trench to get from one side to the other, if it's 6 or more feet deep, we have to make sure that, you know, standard railing has been applied. Some type of walkway or pick or platforms used with a top rail, a mid rail, and a toe board. The other aspect about ladder use is if the trench is exceptionally long, you know, there's a long run, there's a lot of material that's been moved out of the way at one time. Once an employee enters, every 25 feet of lateral movement, every direction, once an employee enters, every 25 feet of lateral movement, every direction that they walk in, there should be another ladder that they could use to get in and out. And then are there daily inspections being completed? Are those being documented? That's not a specific OSHA requirement, but we highly recommend that that paperwork is completed and filled out. If there ever is a problem and you need to justify your findings or prove them, if it's not in writing, it never happened. So this brings us to our next Insta Safety Poll question, Marcy.
Okay, thanks, Mike. So again, I invite everyone to answer the following question. What is the minimum distance that spoils and other materials be placed from the edge of the trench? 1, 2 feet, 2, 4 feet, 3, 5 feet, or 4, there is no minimum distance. So please go ahead and cast your vote. We'll give everyone just a few more seconds to finish up. All right, Mike, let's take a look and see how we did.
All right, Marcy. Yeah, we again spent a little bit more time on that, and that was done purposely because we have had a lot of clients over the years receive citations for this. It could be very easy to want to store items right outside of the cut to where they're easily managed and retrieved, but that's a 2-foot minimum. So hopefully everybody was able to get that one correct. We shouldn't see that being an issue out there moving forward. All right, let's talk about some other specifics. So typically when a trench reaches 5 or more feet deep, The competent person, the employees on site, are required to perform that work while in the safety of some type of protective system, whether that's shoring, shielding, sloping, or benching. The point that I always try to get across to our clients when we perform training is, 5 feet's the technical cutoff, yes. It's in everybody's best interest, though, to take an extremely close look at soil condition, what's going on nearby, because the fact of the matter is an employee can still be engulfed in material at a depth much shallower than that. The old adage is you don't let a vital organ go below grade. If you're in something 3.5 feet deep to 4 feet, maybe technically you're only required to put a ladder in place. Now you crouch over, you're bent over, you're connecting water line, you're performing work on another utility, you're clearing debris. You've simply dropped something out of your pocket and you bent over to pick it up. Well, now you could be below grade. If there's a collapse, you're going to be in the same position, which is essentially completely encased or engulfed by material, as you would if you were in something, for most people, that were in a trench that was 5 or more feet deep. So even though there is a specific depth that would trigger these requirements, it's the responsibility of the competent person to go above and beyond that when necessary. Just to reiterate this, we mentioned the requirement to have a ladder in place. Very, very commonly cited component of this standard. Once you hit that 4-foot depth, a ladder has to be included. It should extend at least 3 feet out above grade, just like the ladder would be required to be set up on any other job site. It should also be secured to prevent it from sliding or moving around, especially when an employee reaches the top, the bottom doesn't kick up in the air. Again, I mentioned this earlier as far as the 25 feet of travel and then coming to an additional ladder to aid in egress, quick egress from the trench. That has to be available. Different types of soil. One of the materials is not listed on this slide. It's solid rock. I mean, typically, if you can assess and prove that you're performing work in solid rock to where there's not going to be a cave-in, there typically wouldn't be a protective system requirement at that point in time. But as you can see from this slide that we have up now, the types of soil degrade as we go, down the alphabet or from A to C. We typically start off with a more cohesive soil, more clay. It's going to hold together relatively well. It's going to keep its shape. We move to type B, where we start to get a little bit more silt and a little bit more granular type material. The likelihood is that you'll still be able to use benching techniques with type B soil. Ultimately, as we approach type C, the material is not going to hold shape. I mean, it's comprised mainly of gravel and sand, material that's likely to be even more hazardous with the addition of water. Now, a lot of companies, just to save themselves a little bit of time and effort in determining soil type, they may automatically classify their soil as type C. So they're more or less erring on the side of caution. The protective systems or techniques that they're using, they're geared towards type C soil regardless. So, I mean, that's always an option out there. I think that's probably one of the more recommended approaches to this. But like I mentioned earlier on, there are ways to determine soil type. A lot of these are subjective, specific to even specific down to the type of sample that was retrieved. If I take a sample of soil that maybe it was type B, somewhere between type A and B soil, but it has a lot of rock material in it, and I try to push my thumb through it, if there happens to be a rock where I'm placing pressure with my thumb, that's going to give me an inadequate reading. And it's going to alter my perception of how stable that soil is. So there are a variety of tests. Typically, the competent person has to perform at least one visual and then one manual test. So this lists the thread, ribbon, wet shaking test, the thumb penetration, drying test, using some devices like the pocket penetrometer and the shear device. Those are all ways that we can hopefully classify soil conditions and that give us an idea of the protective systems that we need to use. But like I said before, ultimately classifying everything as type C is not a bad idea. So that brings us to, I believe, our last Insta Safety poll question, Marcy.
All right, thank you, Mike. So again, I'd like everyone to answer this question. What is the least stable type of soil? 1, type A, 2, type B, 3, type C, and 4, stable rock. So go ahead and cast your response. Give it a few more seconds for everyone to finish up. And all right, thank you. Mike, what's the answer?
All right, thank you, Marcy. Yeah, like we just got done saying, the least stable type of soil is type C. Just to reiterate, it's typically going to be comprised of more sand, granular material. It's not going to keep shape. Typically, any type of material that has any amount of water in it automatically has to be designated as type C. So the hope is that when the soil type's determined, the appropriate employee protective systems are used. And just to kind of throw an additional just tip out there, I've had discussions myself personally with various members of area OSHA offices, and really depending on where the work's taking place, you're probably going to have a hard time arguing type A soil, especially if a lot of the excavation and trench work is taking place near existing utilities or where soil was previously disturbed. It's not going to be virgin soil like you'd find out in the middle of Alaska somewhere. So the likelihood is it's probably not going to be type A regardless. It's probably going to be a more degraded version of soil. So we have a number of different types of options here: shoring, shielding, sloping, and benching. Shoring, we're not going to get into a whole lot. I mean, that's typically not utilized frequently across the country, especially by smaller contractors. Where I've seen shoring over the years by our clients has mainly been in cities, in metropolitan areas where you have large-scale projects going on, where you have a lot of nearby utilities, sidewalks, roads, buildings, a lot of surface encumbrance that need to be properly supported. Now, before we even determine this type of system, we have to make sure that we're not too deep. There are cutoffs for when a trench box cannot just be thrown down in, or we use sloping or benching techniques, and that depth's 20 feet. If we hit that depth or our work takes us deeper, that system that's being used has to be designed by a registered professional engineer. Same thing would apply if we were going to possibly undermine, buildings, railroad tracks, sidewalks. There could be a significant amount of engineering involved with support structures and systems for that type of work. So I wanted to throw that out there before I get into any more. Now, all of these systems that I just mentioned have their pros and cons. Some things to keep in mind when using trench boxes or shields: make sure that the trench is as small as possible. It's as narrow as possible to essentially fit the box in without the option or ability for too much lateral movement, side-to-side movement. We can have a situation where if there's too much space and a trench box is placed, material caves in from one side to the other, could possibly roll it or shift it. You couple that with maybe the fact that the trench box isn't completely recessed all the way in the trench, and you could have one side maybe pinning somebody down below beneath it. So make sure that it's as small as possible, and that excess is backfilled. The shields may not be subjected to loads exceeding those which the system was designed to withstand. You have to have your tabulated data on site too. So keep that in mind. That has to be available. But like I said before, especially with significant depths, the soil type has an effect on just the structural stability of the protective system itself. I mean, type C soil is likely to impose a lot more pressure. Type C soil that's saturated is going to likely impose a lot more pressure on the system. So you have to make sure that box, if you want to refer to it as that, is engineered and designed to support worst case scenario in the event of a cave-in. This is a good depiction of an improper setup. Employees are not permitted to exit the safety of the trench box for any reason, let alone to get in and out while accessing a ladder. So if the work is cumbersome, there are space restraints, then enough room has to be made for the employee to be able to access this equipment while in the protective device itself. Another option to using those shields would be sloping. I mean, essentially we're removing excess material that could otherwise collapse. So this is a pretty handy chart to be able to reference. I mean, stable rock, like we said before, the chance of a collapse is very minimal. Those walls could be 90 degrees. As you go from type A to type C soil, you can see that our sloping angle, our degrees, our ratio from depth to slope increases as well, all the way to a type C where we're looking at about a 34-degree angle. Now, the unfortunate aspect of using sloping techniques is that sometimes our work takes us into areas where we just don't have the room for this. Obviously the time it takes, there are a lot of additional added costs as a result of moving this much material. So that all has to be weighed out. If the site is big enough and the time, the funding, the scope of the job allows for it, this is probably one of the most effective ways of preventing a cave-in for an employee, removing the material that could otherwise cave in at all. And then benching techniques. This is very similar to the sloping that we just got done looking at. We're essentially removing material that could otherwise collapse or break loose in the event of some type of soil disturbance. But there are only certain types of soil that we can bench. Type C soil, like I mentioned before, it's not likely to hold a shape. So this option would, for the most part, be out. But you can see this is a pretty average depiction of a typical bench diagram. We're going to start and more or less go at a 1-to-1 ratio, 4 feet in, 4 feet out, 4 feet in, 4 feet out, and that's for your typical type B, type B soil that's going to likely hold together and keep shape. So, hopefully, we were effective in going over and reviewing a lot of the different types of hazards and conditions and variables that not only a competent person but other employees on site can face and be exposed to. Like I mentioned in the very beginning, a lot of the battle here with this is being able to identify those problems but also have the authority to make the changes. And I would just stress, just like I do with our other clients when I go out and do training, is that with this in particular, entering in an unprotected trench is such a significant risk due to the likely outcome of death. It's not worth it. No trench is worth risking your life over. So I know we covered a lot of specifics as well as just general hazardous conditions as we went through this. To leave you, I would just say do not enter a trench unless it's safe to do so. I know that's a very general way of putting it, but whether it comes to soil type, vehicles, mobile equipment nearby, other forces at play, at the end of the day, try to be able to recognize and identify when a condition is such that the hazards are going to greatly outweigh the reward. So with that, I thank you for your time. I'll turn it back over to Marcy in closing.
All right, thank you so much, Mike, and thank you for taking the time to listen in today. If you are unsure whether your job site needs to be inspected or if your employees need the proper training, call us today to set up a mock OSHA inspection. If you have any further questions, please call Lancaster Safety at 888-403-6026, and we will be happy to help. Also, follow us on social media for more news updates and safety information, or provide us with feedback on either Yelp, Google, or Facebook. We truly appreciate your time and hope you will take advantage of our monthly safety and health webinars. Everyone is invited to attend, and they're always free. Just visit our website or click the link on your screen for more information. Thank you and have a safe day.